In this video, we're going to talk about variable initialization, but to illustrate this, let's use an integer. So this int here is what we call built-in type. This built-in type is also what we call primitive, right? Anything that is built in, part of your compilers, you don't have to download any libraries or plugin to use, and they are already available. It's what we call primitives. So that's one of them. So in order to initialize a variable integer x at compile time, you write int x equals 0. So initialization is not the same as declarations, right? So if you just do this, what does that mean? Well, this is going to give you an uninitialized built-in type, right? So uninitialized built-in type has a value of question mark. Right? So this is what we call undefined, right? You do not want to leave anything undefined in your program. So at some point, you're going to have to remember to initialize it with or assign a values to it. But anyway, so one of the ways to initialize variable is basically, just write out the whole value at compile time. The second part is another way of initializing a variable. And that's do what we call constructor initialization. Now, this is what we call parameterize, okay? Initialization init at construction time. Okay, I'll explain what this is in the next slides. But you can think of every single object in C++, in an object-oriented programming language in general, is made up of classes. So this integer is actually a class. And as such, there is a constructor for it. And this constructor accepts an integer value. And this integer value will become the value of your x at runtime, okay? And the third type of a way of how we can initialize a variable is to use what we call uniform initialization. This is a feature that is available in C++ 11 and forward. Before we didn't have this. So let me just go through the last two ways of initializing a variable using an integer as an example, right, to illustrate how this is done and why this is the case in C++. All right, so the second part of initializing integers use a parameterize constructor. So note that every single class, now this is, I don't know if you guys go through this in your prior classes, but we'll go through this in this class. So for every class that we have in C++, there is a constructor. So you can think of a constructor as a point of entry, right? For you to begin constructing this class at runtime. So constructor is a sort of like a function, but it's not really a function. But what it does is it takes sometimes 0 parameters, sometimes it takes multiple parameters, sometimes it takes 1. So there's always a default constructor. A default constructor doesn't take anything. But in this case, using this as an example, this is a constructor that is referenced by this a pair of parentheses. And at runtime, this parameter, I say this is parameterized, right? Parameterized. Value, right, is an integer. Now this integer is a 0. So what happens is when you instantiate, right, this object at runtime, in this case, you're instantiating it on a stack. You pass in a parameterized value, in which case that would be the value of 0 that you're trying to pass in to construct as x. And that happens, what happens is at construction time, that variable is assigned to be the value of x. So this gives an object at runtime, with a value of 0. So this is construction time or constructor initialization. Sometimes people call it parameterized constructor, right? That's how you initialize your integer variables at this point. Okay, let's talk about uniform initialization. So uniform initialization is interesting. This is a feature that became widely available in C++ 11, right? So obviously C++ 14, 17, 20, they all have these features. So this basically allows the usage of a consistent syntax to initialize variables and objects ranging from primitive type to aggregates and stuff like that. Now, the syntax is this, right? So you specify a type in front of it, right? So this is type, and then you have a variable name, var name, right? And then you have this pair of curlies, right? To specify, what arg1, arg2, right? Arguments 1, argument 2, so on and so forth, ... etc. Okay. So in the example that we have here, previously we had integer, right? X, and then we do this, right? 0. So this means that there is only one argument, and that argument is the value for X at runtime using this uniform initialization. But in general, type could be anything, variable could be anything, right? Args could be anything. So you can see in the popular examples that we have, you probably have seen this too in your homework assignment. If not, you will soon. You specify the type. In this case, this is a vector of template, a vector template with an integer type. And you specify the var name, the curly, and you can basically just assign these values, one at a time to it. But this is all done at compile time, so it's extremely, extremely fast. And what is very, very efficient, using this uniform initialization versus writing a for loop is because for loop is pretty slow. If you had to assign a value of your vector elements with 1, 2, 3, 4, 5 using a for loop, you have to do that at runtime. But this is all done at compile time. Compile time, the logic has is basically capable of creating this vector and assigning a value to it without having you to write extra for loops to it. So that's the point, right? So you can create a set. Set is a collection of elements with no duplicates, and map is a key value pairs. So you can do a lot of these. Now we don't go through a lot of these. These are what we call abstract data containers. Actually, set is the abstract data container. Map is vector is a data structure. In a more advanced C++ classes, we'll go through these a lot. But in this class, we're going to probably be using these two in your homework assignments. But as you can see here, using uniform initialization allows you to quickly assign values to these data structures and ADTs at runtime. And this is a very, very efficient way of doing things without using iterators or a for loop.